Welcome everybody. We're just about to start the live demo on hyaluronan sperm selection using SpermSlow and Pixie. You'll be able to see the presentation on all three screens, so you should be able to get space to see the slides. So we're going to concentrate on hyaluronan selection. We've mentioned SpermSlow. I'll explain the two different methods. I'm going to give the presentation. My esteemed colleague Aaron over there is going to do the hard work and actually show the practical bits, and then we'll take some questions. So what do we know about selecting sperm using hyaluronan? What does it do? What's the advantage? And what are we seeking to get from it? What we know from work by people like Gabor and subsequent papers is that if sperm acquire the ability to bind hyaluronan, which happens at the later stages of spermiogenesis, that's linked to the maturity of the sperm, and also it's linked to a reduced risk of DNA fragmentation in that individual sperm, and it's linked to reduced risk of aneuploidies and overall genetic health of the sperm nucleus. And of course that's important when we're choosing that one sperm that we inject into the oocyte. So whilst sperm preparation techniques generally will deselect damaged sperm, you still run the risk of injecting a sperm into the egg during ICSI that has some DNA breaks, and we want to avoid that. And hyaluronan selection will allow us to do that. Now, there are two ways of doing it, and we'll show you both. SpermSlow is like a PVP. I don't want to present it as an alternative. It's a viscous, hydrated solution with a high concentration of hyaluronan that you use as a sperm selection device. But because it's viscous, it also helps with the handling during ICSI like PVP. So that's one way we'll do it, and Aaron will show you that in a moment. The other way is Pixie. So this is a standard ICSI dish with 3 arrows on the base, and at the point of each arrow there's a hyaluronan plaque that is dehydrated and stuck to the inside surface of the dish. We rehydrate that with medium, allow sperm to swim to that hyaluronan plaque, and as the hyaluronan becomes hydrated and expands, hyaluronan absorbs up to 1,000 times its own weight in water. As it expands, the sperm that have receptors to hyaluronan bind to the dish, and they'll spin around, and then you can pick them up and inject, knowing that there is very, very small risk of DNA damage. And if you look back at the original papers, the one by Yagchi and colleagues showed using fluorescent markers that 99.1% of the sperm that are bound in a Pixie dish have no DNA breaks. So you've got less than a 1% chance of injecting a sperm with DNA damage. What does that mean to clinical outcomes? Well, there are a number of studies. There are 2 particularly large randomized controlled trials. The largest one was done across a number of centres in the UK and included almost 3,000 patients. What that showed is that although there wasn't a statistically significant improvement in the live birth rate, what they did show is a significant decrease in the rate of miscarriage. And as hopefully you know already, the most robust data around sperm DNA fragmentation is its link with pregnancy loss. So that makes sense that if you have a way of deselecting DNA damaged sperm, you might have an impact on miscarriage. Now, what this study also did is they continued and did a mechanistic analysis. This was done by the team at the University of Birmingham principally, and they did a subsequent study which shows a really interesting observation, which is when a woman becomes pregnant, you'll see down here the predicted live birth rate on the y-axis. When they become pregnant, you expect an age-related incidence of miscarriage, and the chance of miscarriage goes up with female age. What they showed in the study from the University of Birmingham is that if you use pixie, you'll see the horizontal line there. Deselecting DNA-damaged sperm protected against the age-related increase in miscarriage, so you end up with that horizontal line. They also showed a paternal effect of paternal age rather than maternal age, but that was much less significant. So the overall message really is that the hyaluronan binding, whether you use SpermSlow or the pixie dish, is linked with reducing the chance of using DNA-damaged sperm during ICSI, and we know that that sperm DNA damage is linked to the risk of miscarriage. So by using these techniques, we can hopefully maintain the chance of a healthy pregnancy continuing to term and reduce the miscarriage rate. So what we'll do now is I'm going to hand over to Aaron, and he will show you on the microscope over here how we actually do those techniques. Aaron.
Okay, thank you, Dave. So Dave's shown a little bit about how hyaluronic acid can be used to select sperm with less DNA fragmentation. What I want to show is a bit of the practical aspect in the laboratory of how we use these different techniques, the pixie dish and SpermSlow, how we prepare it, and then how we can select the sperm. So this is a pixie dish. It's just like a normal ICSI dish that you would see used for an ICSI in the laboratory. What you probably can't see from where you are is that there's 3 small arrows on the dish. I'm going to show you on the screen. Now you can look at all 3 screens if you can't see this one. You see the three arrows, okay? What those arrows are indicating to me is at the end of each arrow there's a small drop of hyaluronic acid. And you can see this is the drop of hyaluronic acid there. So what I'm going to do is I'm going to basically place my prepared sperm for the ICSI over that hyaluronic acid, and that's where we're going to select the sperm which are binding to the hyaluronic acid. I'll show you the process of that now. So the first thing to do is I'm going to take a normal Heapies or mops buffered media that you would use for ICSI, so using without CO2. I'm just taking some 10 microliter drops. And I'm going to place at the end of each arrow, I'm going to place 10 microliter drop of normal media, Heapies or mops buffered media that we would use for a normal ICSI. So hopefully what you'll notice is I've made a tear-shaped drop. And I'll explain in a minute why I've made the drop that shape. So basically the arrows are there just to indicate to me where I need to place my drop of media. Okay, there's my third drop. Now I'm also going to use normal PVP. And in the center of the dish, like we would normally prepare an ICSI dish, I'm going to place a drop of PVP. The volume here doesn't matter, it's just the volume that you would normally use for a normal ICSI. So we're not actually going to use the PVP like a normal ICSI to immobilize the sperm. The PVP, in this case, is just going to be used to load into our ICSI injection pipette so that we can maintain a good control. Okay, 1 drop of PVP. I still haven't added any sperm to the dish. What I'm going to do now is place some oil on the dish so we can prevent any evaporation. So we cover our dish with oil. Okay, so that's all done. Now we can be calm. We don't have to worry about any change, any evaporation or any changes in osmolarity. Now I've got here my prepared sperm sample at the normal concentration that you would use for an ICSI. So just like you're going to do a normal ICSI. And what I'm going to do is in each of these drops that I've prepared, I'm going to place a small amount of the sperm preparation. The reason why I've made this tear-shaped drop is because what I'm going to do is I'm going to place the sperm at this end of the drop so the motile sperm will go swimming down and then arrive to this area where the hyaluronic acid is. So that will hopefully clean up our sample and we'll get more motile sperm in this area where we're going to select the sperm. And what I'm actually going to do in each of these 3 drops that I prepared, I'm going to make a slightly different concentration of sperm. Now I'm just going to do it. It's not a specific volume that I'm going to put in or a concentration. I do it by eye using the stereo microscope, and I'm going to use the stripper tip to take a small volume. I'm going to put a small amount in the first drop, a little bit more in the second drop, and a little bit more in the third drop. And I'll explain a bit why it's nice to have 3 different concentrations in a minute. So I'm just doing this by eye using the stereo microscope. So I place a very small amount there. A little bit more in the second drop, and in the third drop I'll put quite a lot. Okay. So now that sperm will migrate down to the area where the hyaluronic acid is, and hopefully it will start the sperm, as Dave said, the sperm which are express receptors for hyaluronic acid, which have less DNA fragmentation, will start reacting with it and they'll bind, and we're going to see that in a minute, what this binding effect looks like. The reason I did 3 different concentrations is if we have, let's say if we have a really good sperm sample with low DNA fragmentation, there's probably going to be a lot of sperm binding in that area, so it's going to be a higher concentration of bound sperm. So in that case, I'll probably go to the less concentrated drop, which will help me to be able to select those sperm. If there's a lot of DNA fragmentation and we have very few sperm binding, I might need to go to the more concentrated drop to find the sperm which is bound. So it's just some little practical tricks to help us doing the process. That's my pixie dish. I'm also going to prepare a SpermSlow dish now, okay? So SpermSlow, it's the same theory behind how it works. We're going to use hyaluronic acid again to select our sperm with less DNA fragmentation. Here I just use a normal ICSI dish, okay? What I'm going to do first of all, in the middle of the dish, I'm going to place a 10 microliter drop of, again, my Heapies or Mott's buffered media for using without CO2. Just 1 drop, this would in the middle of the dish, okay? Now, I'm going to get 1 small drop, that drop's about 10 microliters. Now I'm going to get 1 small drop of about 2 microliters of my sperm preparation. Of SpermSlow, the SpermSlow media. So SpermSlow, it's like PVP, it's a viscous material, but the viscosity comes from the hyaluronic acid which is in it. And what I'm going to do here now is, like I said, a very small drop. Between 2 to 5 microliters. Okay. So there's my drop that I prepared. What I'm going to do is place next to, on the right hand side of this drop, a very small drop, 2 microliters of SpermSlow, okay? And what I'm going to do, I'm going to use my pipette and join those 2 drops up to create a bridge, like that, okay? So now what we have is an interface where we have, on the left hand side, we have media, and on the right hand side, we have SpermSlow, which is the media which contains a hyaluronic acid. Now, on the other side, on the right hand side, sorry, the left hand side, I'm going to take a bit of my sperm preparation again. And the same again. I place one small drop. So this is my sperm preparation. And with my pipette, I'm just going to make a small bridge and join the two up there. Okay? I'm going to cover it in oil quickly so we don't get any evaporation again. If we were doing a normal ICSI, we would place drops for our eggs in the dish as well, but we won't do that today. So again, cover with oil to as quick as possible so we don't get any changes in the osmolarity of our media. Okay. So that's the difference between preparing the pixie dish and the SpermSlow dish. I'm going to go over to the inverted microscope now, and we're going to have a look and see what the difference is between the binding, how you can see the different binding between these two dishes. So if everyone will just follow me over here. Okay. I'll show this. I'll use that one, I think. Okay. This is the arrow. This is the arrow that you can see now on the dish, okay? So, and what you see here is, well, this is where the media starts, okay? So this is not the hyaluronic acid, this is where the drop with the media and all the sperm starts. And what I'm going to do is start moving up, and you'll see, hopefully. Now, can everyone see there's a kind of a circle here? It's going around here. It's actually going around there. This is the area where the hyaluronic acid is on the dish. Okay, it's in this circle within that drop that I've created. So what we're going to do is we want to select sperm from within this zone here. And what we're going to do, we want to select sperm, which we can see they're motile because they're moving their tail. They have a good morphology, but we also have an extra selection criteria, which is that they're expressing the receptors for hyaluronic acid, so their head will be bound to the surface of the dish. So let's have a look and see if we can see a bit better. Hopefully what everyone can see is there are some motile sperm there which are not bound, which in this case, if you did a normal ICSI, we might select these sperm because they look like they're fine, they have good motility, good morphology. But in this case, these are not the sperm we want because these are the sperm that may have more DNA fragmentation. So let's go to a higher magnification and see if we can see the effect. Okay. So this is within that area, that zone of where the hyaluronic acid is. And hopefully everyone can see. We have some sperm which are swimming and are not bound, okay? This dish I actually prepared about 30 minutes ago to make sure that everything is ready for the demonstration. So what we can see now, there's actually quite a lot of sperm which are bound. So these are the sperm. This is what we're looking for. For example, you see the head is stuck, the tail is moving, quite often they'll be spinning around. And what we're going to do is we're going to select these sperm with our ICSI pipette. So I'll go first with my ICSI pipette into the PVP drop. I'll load PVP into my ICSI pipette so you have a good control. Then I'm going to go into this drop where the hyaluronic acid is. I'm going to select a sperm which is bound. I'm going to take that sperm back into my PVP drop. And let's say, for example, if I had 5 eggs, I still don't have the eggs in the dish, okay? We leave that to the last minute. If I had 5 eggs, I would select between 5, maybe 7 sperm, put them in my PVP drop, take that dish back then. I would warm it up, give it another 10 minutes to warm back up in the incubator, make sure everything's at the right temperature, then put our eggs in, and then we have our sperm already selected, and we can go and we're going to break the tail of the sperm, because at this point we're not breaking the tail to immobilize, they're already stuck there. And then we can do the ICSI quite quickly. So this is how you see the effect of the pixie dish. Let's have a look now and see the difference with the SpermSlow. Okay. So 4 times, okay. This basically is the middle drop that I prepared. The one with no sperm, no SpermSlow, just the media. The sperm I placed over here, and the SpermSlow I placed on that side of the drop. So what I effectively did was I created a small microfluidic channel, so the most motile sperm are going to swim towards the SpermSlow. And what we're going to do is I'm going to go to the edge of the drop, the upper edge of this drop. I actually probably prepared the concentration a little bit too high for today, but we'll see how we go. And I'm going to go along this drop, and if I follow the edge of this drop along here, eventually I'll get to the area where the media contains hyaluronic acid, which is the SpermSlow. So let's go up to another, to a higher magnification. So hopefully what you can see here, we have really good motility. The sperm swimming freely with a progressive motility. As we get along there, we are going to arrive to a place which is like the interface between media and SpermSlow, where the sperm which have the receptors for hyaluronic acid aren't able to penetrate through. So they'll still be motile, they'll still be beating their tail, but you'll see that they'll slow down, and what we'll start to see is kind of an interface where there's more sperm which can't get through. So let's see if we can find where that is. Okay, can you see a difference now how there's still motile sperm, but they're starting to find it more difficult to penetrate through. If we go further over, you can see it's a higher concentration of SpermSlow here. So more and more, these sperm are really starting to find it difficult to penetrate through the SpermSlow. And we'll go even further over, and there's going to be even less sperm. And what you'll see, so obviously the motility, the progressive forward motility is a lot lower here now, because these sperm, it's a pretty good sperm sample. A lot of the sperm, like the pixie dish, a lot of the sperm are reacting with the hyaluronic acid. So you can see a lot of them are really finding it difficult to penetrate through SpermSlow because they've reacted with the hyaluronic acid. So these are the ones we want to indicate. If we go right over here, okay. If you have if I go right to the very right-hand side of the drop, here, this sample, we don't really have any sperm that have been able to, so far, been able to penetrate through here. But if we did, we wouldn't select these sperm, because these are the sperm that have good motility, but they haven't reacted with the hyaluronic acid because they've been able to get through to this part of the drop. So this is a little bit different to a normal ICSI, because a normal ICSI you might say, I want the good motility ones. Here you want the ones that have been stopped at that point. So we're going to select those ones. So this is a practical demonstration of how it works. Dave, can I ask you some questions about SpermSlow? Maybe we can answer.
You can. I'm not sure my microphone
I don't know if we can use my... Yeah. Okay. Is there any questions? And I'll repeat the question on the microphone.
So what's the difference if I pick the sperm from the border of the drop?
On the pixie dish? Yeah. Yeah.
From the middle of the
Okay. So there was a question about where to select the sperm in the hyaluronic acid drop in the pixie dish, which is a good question actually, because what you'll see, if I go back to my pixie dish, okay, this is the border of the drop here, okay? This is the inside where the hyaluronic acid, this is where there's no hyaluronic acid. We don't want to select these sperm here, which are on the border. We want to select the sperm which are in the middle. The reason for that is on the border, in the process of fabricating the pixie dish, they place a drop of hyaluronic acid. So on the edges of the drop, it can be slightly elevated. So what we don't know here is this sperm reacting with hyaluronic acid, or is it just hitting a physical barrier which is stopping it? So we're going to go to these ones which are in here. Now this is a really high concentration. I would prefer, and that's what I said, in this case, I would go to the drop which has the lower concentration. It's going to help me because this would be difficult for me to select one sperm at a time, and it could be a bit complicated. So in that case, I go to the lower concentration drop, and yeah. And you can see in this case, it's probably a good sperm sample. There's probably low amounts of DNA fragmentation. That's why we've got such good binding here.
Then it doesn't matter if I load the same concentration of sperm sample, three of them.
So does it make a difference if we load a different concentration in each drop? As far as binding, no. But as far as the concentration of, like practically of trying to be able to catch the sperm, it's going to make it easier or more difficult. So yeah, these are the small little tricks that we try to show when we do demonstrations to help people in doing it. So we'll be here now. So we'll probably disconnect the microphone, and what we'll do is, if anyone wants to come and have a practical play, we can try catching some sperm and sitting down with anyone who wants to come and talk with us. So thank you everyone for listening.